In this video, we're going to talk about some characteristics of both the sine and the cosine curve. I'm going to use the sine curve, the sine function here, to demonstrate those characteristics. There are four main things we need to consider, but we're going to start with the first three that might make it a little bit easier to kind of visualize. So I'm looking at the sine curve, and I notice a couple of things. We said that sine and cosine curves have a maximum value, right? And they have a minimum value. Well, in this case, the maximum value is 1. Now, I shouldn't say in this case. I should say in the parent function, the maximum value is 1. Why? Because the highest it's going to go is y equals 1. The minimum value is negative 1. Because the lowest it's going to hit on this graph is negative 1. Well, exactly halfway between those two is what we call the midline. And the midline is exactly what I just said. The halfway point between the maximum and the minimum, that's what we call the midline. And the midline has to have a location. So I'm going to say the midline is at y equals 0. So in this case, we know what the midline is. We can see it. We know that it's halfway between the very top and the very bottom. So how do I figure it out if I don't know where it is? Or by that I mean, what if they were to shift my graph up and down? What if they were to stretch my graph and we introduce transformations? We're going to do that in the next video. But I want you to kind of, save this picture in your head. That if I know the maximum, if I know the minimum, the halfway point is the midline. That's different than this. We're going to find out what this distance is. Or what this distance is. If the midline is exactly halfway, then these two distances should be the same. We call this the amplitude. The amplitude is the length or the distance from max to mid, or from the midline to the minimum. So from the maximum to the midline, or from the midline to the minimum, because the midline is the halfway point, they should be the same. And in this example, the amplitude is equal to 1. But it's measuring the distance. Because it's measuring distance, amplitude is always going to be a positive value. Whereas the midline, because it's telling me a location, it could be positive if I put the midline above the x-axis, or it could be negative if I put the midline under the x-axis. So those are four, if you think about the max and the min, 4 vocabulary words you need to know about the sine and cosine function graphs. They all have a maximum and a minimum, they all have a midline, and they all have an amplitude. The other thing they have is something called a period. And the period is the distance or the length it takes for one of the cycles to complete. Now remember, we said the nice thing about sine and cosine is that they have a pattern that repeats over and over again. They're very predictable. Well, here's the pattern. There's a hill, there's a valley, and then the pattern starts again. There's a hill, there's a valley, and then the pattern started again. So the distance from the start of this pattern, which we call the cycle, to the end of the pattern, or the end of the cycle, this is what we call the period. So the period is the length of the cycle. How long does it take for the cycle to complete? Well, from start to finish, I'm measuring that length. I'm going to point something out. When we talk about midlines, we're talking about y locations, right? When I talk about amplitude, I'm talking about vertical distance, so I'm using y values. But when I talk about period is horizontal distance, so I need to use whatever these x values are, and I always subtract right minus left to get a length that's horizontal, just like I always subtract top minus bottom to get a length that is vertical. In this case, the original parent function has a period of 2 pi. Where have we heard that number before? 2 pi. Well, if you remember the unit circle, we started measuring at 0, and then we kept opening angles all the way. Wow, that's a pretty bad angle. Angle, 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 angle. And if I went all the way around, how many radians was that? That was 2 pi radians. So remember, the sine curve is made from the y-coordinates of the unit circle. And so if the y-coordinate at 0, at this point right here, let me use it in a different color. The y point right here, the y-coordinate of this point right here is 0. Well, that's why this y value is 0. But as I move in this direction, the y values are getting higher until I get to this y-coordinate. Well, this y-coordinate is 1. That's why this maximum is 1. And then the y-coordinates get smaller and they get closer to 0. This curve gets smaller and closer to 0. And then they get, my y-coordinates get more and more negative, all the way down to -1. And this goes down to -1. So this is really just tracking the rotation around the unit circle, but it's only graphing the y-coordinates and their behavior. How long did it take us to go all the way around? 2 pi. How long did it take the cycle pattern to complete? 2 pi. That's why it's 2 pi. But these are the main ideas that we use this week. In order to describe sine and cosine functions, we need to know where's their midline, what is their amplitude, can I figure out the maximum value, can I figure out the minimum value, can I figure out the period. Those 5 things are really the focus of this week.